QSO Today episode 211, Justin Johnson, G0KSC. This episode of QSO Today is sponsored by ICOM America, makers of the finest HF, VHF, and UHF transceivers for every level of amateur radio operator, and by QRP Labs, makers of the QCX single-band transceiver kit, and so much more. Please support the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth, 4Z1UG, your host. My guest today changes the way that we think about Yagi antenna design by optimizing signal-to-noise ratio versus gain. Justin Johnson, G0KSC, tells his ham radio story and how it led to the founding of his company, Innovantenna, and his approach to antenna design that produces amazing results. If you're reconsidering your antenna system, then you'll enjoy this QSO Today with G0KSC. G0KSC, this is Eric, 4Z1UG. Are you there, Justin?
Sure I am, Eric. How you doing?
Justin, thanks for joining me on the QSO Today podcast. I'm great today. Before we start, I saw on your QRZ page that you have two QTHs. Can you say where they are and where you are today?
Sure. I have one home which is in Canvey Island, Essex, UK, and that's on the River Thames estuary, just between London and Southend-on-Sea. And the second is a holiday or vacation apartment, which is in Torrevieja in Spain, which is near Alicante, so on the southeast coast of Spain. Both are very close to the sea, and the Canvey Island location is actually below sea level and has a seawall all the way around it. And one of the great things about that is it makes it very good for radio, because there's a high saltwater level just below the ground, and it's a similar situation in Spain also, which has we're around 100 meters off of the Mediterranean Sea one way, and about 300 meters that's to the south the Mediterranean is, and around 300 meters to the north are some very large salt lakes in Torrevieja. So both locations are pretty good for radio.
Now, it's pretty common for Brittoners to have houses or apartments in Spain. It seems to me that there seems to be a lot of UK people that go back and forth. Does that seem to be the case? Is there a large expat community in Spain?
There certainly is, or was. One thing I did forget to mention is that I am in Canvey Island in the UK today. But it was a very big movement to purchase a property in Spain some years ago. We seem to be overtaken now by people in Northern Europe, Sweden, Norway, Denmark seem to be buying a lot of property in Spain, and a lot of Brits seem to be moving back for some reason. I think maybe some of the fears around Brexit are causing those wobbles, if you like, in comfort factor. And as a result, they're moving back to the UK.
Oh, very interesting. Can we start at the beginning, then, of your ham radio story? When and how did it start for you?
Well, controversially, my ham radio story started in CB radio. I took a family visit when I was a very young lad to Florida. We had an aunt that lived there, and my parents took myself and my brother to Florida to see her. And her and her husband at the time had an RV, and they were located in Orlando, and we took a drive down to the Everglades to fish. And I was just in awe of these huge big rigs and the way they were decorated up, and the great big horns that they had on the tops of these trucks. And many of them had these two antennas, one on each mirror. And I asked my parents what this was for, and at one of the stops, this trucker showed us inside this rig and this CB radio thing, and that's where my interest in radio came from. So I didn't do too much with ham radio until I'd finished high school, but as soon as I finished high school, I then took one of the tests. I didn't do the exams. I sort of read up everything. Sorry, I didn't do one of the courses. I'd read up everything that I could during my school years, and just took an exam and obtained G7 BHF, which was a UKB license call in the June of that year, which was, I think that was 88. And in the December of the same year, I took the Morse test and was awarded G0KSC as a result.
So this is the call sign that you've had with your, would you say is it an extra class license or the most advanced license?
It is, yeah. It's the most advanced license in the UK.
And what do they call that? What's that level, license level?
It's an A class.
Oh, A class.
Yeah.
Okay. And unlike the American extra class and advanced class licenses, what's the maximum power that you can operate in the UK, say in the 80 through 10 meter?
It's 400 watts is what you're allowed with the license without any exceptions. You can apply for higher power limits, providing that you can give information with regards to field strengths at the boundaries of your property. And I think that limit was added because generally, as I have here, you have very small lots. So it's a postage stamp kind of garden space. So with much higher power levels, you could have very high field strengths into neighbours' properties. So providing you've got a bigger property and the borders are not right on top of the home, then you can apply to have up to 1,500 watts.
Do you remember the first rig that you had?
I do. The first one that I purchased was a Kenwood TS140S, which was a brand new radio or a new model that had came out, and it was a new radio that I purchased from one of the local stores to here, and it was a very big purchase for me because I had started to work. I'd got a job as a sales guy with a photocopier company, so I was in at the front end as far as earnings was concerned, compared with a lot of my buddies. So I had a car provided by the company and then commission. So it was something which I didn't dream that I'd be able to afford to do for quite some time. But I waited a few months and that's what I bought.
Well, that's pretty cool. And what kind of antenna did you have at that time with the Kenwood TS140S?
That was a Butternut HF6V was one of the ones that I was using for HF, and that was the main HF one. And that was one of the because it was a fairly small lot again where we were at the time, and couldn't get a great deal of radials out. So then it started to experiment with wires and altering wires, reading up on wire antennas and how best to get performance from those. And that's really where the interest in antennas started to come from for me, being able to make something as good as you could buy it.
Now, you said that you got your amateur radio license late in your childhood. I guess it was the end of childhood. Did ham radio play a part then in the choices that you made for your education and career?
Not so much for education. Just to come back on that, I took my ham radio exam after I finished high school. And while the culture here in the UK is very different now, and the college and university route is something that's commonplace, I'm from fairly humble beginnings, so it was one of those, certainly where I was living and where I was from, that you finished high school, you may go to college for a year or two before going into the workplace. I finished high school, and I mentioned earlier I got a job working with a photocopier or a Xerox sales organization. A cousin of mine was doing that with a company in London and earning very well. And I think I was fairly outgoing back then, and I just walked into, well, the same as I am now, I guess, but I just walked into a business that wasn't far away from where I lived at the time and said, I want a job selling your stuff. And they was pretty impressed that somebody's walked in the door saying, I want to sell your stuff, which is, of course, what you need to do with other businesses to sell your stuff. So I was earning sort of a butt beyond my years, if you like, straight away. So I had no reason to go and no requirement, I guess, for me to go into further education. But what I did do is I spent a few years selling photocopiers and then thought to myself, well, where could I go along slide off into the communication route where I'd get a bit of a better feel for the product and maybe have a better in-depth understanding. And I diversified into telecommunications, started to sell pagers before the SMS ability, before we had digital cell phones. So that was the first route into the communications sales or technical sales roles.
And who did you sell? I'm just curious. I had a pager business in the 80s and 90s, and even had British Telecom come visit. Who were you selling pagers for in those days?
The company was called Page One Communications. The business was based in Brentford, which is west of London, and they were looking to gain contracts with companies and organisations. So there were many hospitals, certain parts of the NHS, the rail networks in the UK, and one of my remits was institutional finance. So some of the very big banks in the City of London.
Oh, that's pretty cool. No, I remember those days. I think if you showed a pager to a youngster nowadays, they would have no idea what it is. But that's right, like a lot of other things. What is your current rig?
Well, I have several. In Canby, I have the Flex 6700. In Spain, I have the Flex 6500. And in both locations, I also have an FT847 Yaesu. And the reason I have that particular radio is the European version, the UK version of the FT847 was enabled with 4 meters, the 70 megahertz band. So while the Flex 6700 and the Flex 6500 also cover 4 meters, which is one of my favorite bands, especially in the summer, the 847 gives me a backup, but it also gives me a route to the 2 meter and 70 sems bands too.
And what do you like about 4 meters? I don't think I've actually spoken to anybody that actually spends any time on 4 meters.
I think what it is, if you're an avid HF guy and you look at 10 meters and think, well, yeah, it's okay, but it's not open all the time. That's part of the attraction. And with 6 meters and then 4 meters, it's that and then some. And when I try to explain this to people that are non-hams and why I'm interested in the bands that I am, for me, and I know that some people have a point of view about this, but for me, 20 meters is a bit like going out fishing in a boat and throwing a grenade over the side and just scoop up the fish as they start floating to the surface. Whereas 4 meters is more like you're fishing in a lake where you've only got a chance of catching something every few months of the year, and there might be 1 or 2 fish to catch, but they're prize fish when you catch them. At the moment, there's new countries that are coming on with the award of 4 meters each year. So you've got these chances to have firsts and distance records. And surprisingly, with the introduction of controversial modes such as FT8, the ability to cover some distances are quite vast. You look at some of the QSOs that have been recorded on YouTube, and there's been at least one QSO between South Africa and Greece on 4 meters. So there are some distance capabilities within the band, but very, very few and far between. So you've got to be there at the right time.
And 4 meters, like 6 meters, is best during the summer months? Exactly,
yeah. I think the best into Europe at the moment on 4 meters is Bahrain to Wales, GW. And that was done in June. So yes, June is the highlight of the month, but 4 meters is open quite often during that time.
And then what bands do you like to hang out on during the rest of the year? What's your winter bands?
Well, my operating is 90% listening most of the time because I'm working developing modeling antennas. As well as answering questions. I have hundreds of emails each week from the G0KSC website where people are self-building antennas. And while a lot of those questions are repetitive, there are normally some slants off that are personalized to the requirements of the individual. So I spend a lot of time doing those. So I will be listening. I'll have the headset that I've got on now. And in the winter months, it'll be 40, 60, and sometimes 80 meters in the evenings. But with the introduction of the receiving loop, I now have the ability to hear some real DX on 160 meters as well. So at the back end of last winter, 160 meters was also taking an interest for me.
And what operating mode are you spending more time in the digital modes, or do you operate single sideband and CW as well?
Yeah, single sideband and CW. Generally, if I'm listening while I'm working, then it will be SSB that I'll be listening to. If I'm operating, especially if I'm up real early in the morning, then I'll be listening down the CW end. But in particular, before I had the receive loop, because the real DX, because of the noise level, I was only going to be able to hear. They might be able to hear me okay, but I was only going to be able to hear them okay with the exceptional filtering capabilities of the Flex radios, and what do you call it? The very minute signals that are coming through that noise can be detected if you've got those filters and a decent set of headphones on.
Well, I was going to actually ask this question later, but I'll ask it now. I read on your QRZ page that you operate a 43-foot vertical antenna for transmit and this receive loop that you've just described. I've often thought that this might be a solution for a noisy urban environment. Can you speak more about it and how this combination works for you? Yeah,
it works well on the Flex because it has a separate receiver output on a VNC or a receiver antenna output. So there's no complex switching or chances of me sending any transmit RF up and taking out the receiver on the loop. But this is around 3 foot across, around a meter across this loop. It doesn't need to be particularly very high. Mine is around 8 feet from the ground, and has a masthead preamp at one end. It's fed with 75 ohm coax, and at the rig end it has a small bias T, which supplies power up to the preamp in the base of the loop. Now, generally the signals received are at a lower signal strength than they would be on the 43-foot vertical, but the difference in signal to noise ratio is quite marked. On 40 meters, for instance, I can see between 3 and 5 S points difference between the noise floor and a given signal. And in many cases, on, say, 60 meters, for instance, when I first put the 43-foot vertical up, it seemed as if during the day that there weren't any users on the band in the UK. That was just, or it was just the case that they were being covered by the noise floor. Because as soon as I had the ability to switch between the receive loop and the vertical, the noise floor dropped so drastically that you could see all these QSOs that were taking place.
And does the receive loop, is it a magnetic loop in the sense that it has a capacitor that you're adjusting in order to change the resonant frequency of the loop?
No, it's very different to the magnetic loop or the traditional magnetic loop. In actual fact, the main lobes from it are opposite to what you would expect from the traditional transmit style loop. So it is very different in that sense. The other thing is that with the transmit style loops, with the big coil, the big capacitor you were mentioning, they're extremely narrow band. They'll have 20 or 30 hertz coverage before they need to be retuned. This is a broadband receiving loop that goes from sort of 1 megahertz up to 30 megahertz and doesn't need to be retuned at any point in that range.
Does the outside diameter of the loop itself make a difference in terms of it being broadband, or can you make this receiving loop out of 14 gauge wire?
I haven't looked at the logistics or the theory in too much detail about these things. There's I think there's 3 production versions that I know of. One is the Wellbrook. This one is the Pixel loop, which is now owned by DX Engineering, and an MFJ producer version. and they're all at this diameter or very, very similar. So I'm sure that there must be a significance about the bandwidth of the loop and that size. Perhaps with a slightly bigger loop you could go down a bit further, but maybe it wouldn't quite cover up to 30 megahertz perhaps. And
when you transmit, do you turn off the power to the preamp in the loop?
Yes, how it works and the way that the pixel loop is set up. On the back of a Flex radio, you have 3 phono female sockets for switching or doing the PTT onto, say, 3 different amplifiers. How the preamp's set up on the pixel loop setup is that you use a second, if you're running an amplifier, use a second one of those into the loop, and instead of switching the amplifier on, it switches the preamp off. So when your preamp or when your amplifier comes on that's going on to, say, the 43-foot vertical, the received preamp is switched off at the same time.
Now, the 43-foot vertical has a antenna tuner at the base? That's
right, yeah.
Is it a homebrew tuner, or is it something that you purchased and put at the bottom?
No, that's a purchased one. That's one of the MFJ remote tuners. The reason that I chose that one is, again, it uses a bias T to supply the feed or the power up the coax to the remote tuner. So it's only coax cable that needs to run to the antenna, and it has quite a comprehensive set of memories for each band and various different parts of the band. So once it's tuned onto a band and you go back and just briefly touch the tune button, it's back then to where it needs to be for that particular frequency.
And now this message from ICOM America. Heard it, worked it, logged it. It is time to get the ICOM transceiver that is best suited for your lifestyle. ICOM offers a variety of high-performance and innovative transceivers that fit your ham radio budget. See how you can make the most out of the contest season with one of these fine transceivers. The IC7851 has the competitive edge that you've been looking for and the endorsement by Dr. Ulrich Rohde, N1UL, on episode 208 of the QSO Today podcast as being the best transceiver on the market today. Raise the bar and hear what others cannot with this flagship HF and 50 MHz transceiver. This is due to ICOM engineers focusing on the new local oscillator design that drastically reduces phase noise. This noise reduction and purity of the LO results in an RMDR of 110 dB, allowing you to hear the extremely weak signals, making the IC7851 the perfect rig for making contacts at the bottom of the sunspot cycle. In addition, this fine rig has a spectrum scope, dual receivers, and a digital voice recorder. The IC7610 is the SDR every ham wants, and just in time for contest season. This high-performance SDR has the ability to pick out the faintest of signals in the presence of stronger adjacent signals. The new ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. Its features include RF direct sampling system, 110 dB RMDR, independent dual receivers, and dual digicell. The IC7300 has changed the way that an entry-level HF transceiver is designed. This rig is a high-performance, innovative HF transceiver with compact design that will far exceed your expectations. It includes an RF direct sampling system, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, internal antenna tuner, and an SD card memory slot. No matter which ICOM rig you choose, you'll be a winner. Be sure to check out these fine rigs at www.icomamerica.com, and when you finally go to make your ICOM purchase, be sure to tell the dealer that you heard it here on QSO Today. And now back to our QSO. One of the ways that I find QSO Today guests is that I search the internet for experts in amateur radio. I found your website and your Innovantenna website, where you're the designer and builder of a line of antennas, HF, VHF, and UHF, for working DX and EME or moon bounce. How did you become an antenna designer and builder?
Well, this really started out from the early days of radio for me. I mentioned earlier on that I had the button at HF6V and then started to experiment with wires. And from that time, I would build and make my own antennas and really experiment with those and see how things progressed, how they worked, make changes. And while I would reference books and the internet, I'm very much one of these that wants to challenge. And okay, well, you say that will happen, or this will happen if you do this. Let me see for myself, and let me see what happens if I add X, Y, Z into that. So my experiments were very much just in wire type antennas, and that was up until it was probably as soon ago as maybe 15 years ago, and I wanted to look at making something for 6 meters to go onto 6 meter band. I operated with a delta loop, and more of an ice cream cone style delta loop. So instead of a 70 ohm feed point, that would have around 50 ohm feed point, so lower and broader band from a SWR perspective. But wanted to get something that was going to be produce a bit of gain and maybe suppress a bit of noise in certain directions. And that's when I found the YU7EF website. Now, POP has a website very similar to the G0KSC one, where it publishes a number of antenna designs or Yagis. And he gave me some dimensions for a 3-element 6 meter Yagi, which worked very well indeed. I asked him how he did it and with what software and what was involved. So he was one of the Elmer for me as far as antenna design, and introduced me to the concept of low noise antennas. And through experimentation, through looking at what was around and my particular needs, where I had a lot of noise that I needed to suppress, I started to experiment with the different designs, namely the LFA or loop fed array Yagi. And I had a number of people saying you should publish this because it's really good information. It's real useful to a lot of people. A lot of people suffer with noise. And Joe Kraft, who runs Dubus magazine, somebody had spoken with him and suggested this, and he asked me if I would like to publish information on the LFA. So that's where it all started. I published the first article in Dubus magazine, and then I went on to produce the website and publish a few designs on there.
We're all used to what we think is standard Yagi design. What makes a Yagi an LFA Yagi?
It's very distinctive to look at. Basically, the driven element is a rectangular loop, a rectangular or shaped loop, which is laid flat on the boom between the reflector and the director elements. And while I think a comment made previously was this Moxon antenna on a Yagi boom. It looks like, but with a Moxon that has a driven element which is bent, has the tips bent back towards the reflector, and it has a reflector that has the tips bent forward towards the driven element, and there is an insulator either side of the antenna. So it's a 2-element Yagi. With the loop on an LFA, it's a full wave loop. So there's no breaks in that at all. Now, what happens or how it works is it's not an exact science, but if you were to remove that loop and you would put a traditional dipole-fed arrangement in between the reflector and the directors, it would be a very low impedance antenna. And one of the common known facts is that on a lower impedance Yagi, you tend to get higher performance in terms of gain per foot of boom and front to back ratio. Now, if you just remove that loop and put a dipole there, you'd probably have to move the reflector a little bit closer in to get things to work, but it would be around the 12.5 ohm region. With the LFA and with the loop, by placing the loop in a position of a 12.5 ohm Yagi, you end up with a 50 ohm direct fed antenna. That's the first thing. So you haven't got any matching devices. And the problem with matching is that in many of the products that we use to model antennas, they don't include the losses that are seen within matching devices, and neither the noise that's induced by matching devices. As with anything or any transformer known to science, there isn't one that's 100% efficient. So part of the inefficiencies of matching is loss, and the inefficiencies also mean that noise is created. On bands such as 2 meters at 432 and up, that can be significant to receiving weak signals. The next benefit is that the flat sides of the loop that are either side of the loop, where the tips of the Yagi elements would normally be, those side sections are 180 degrees out of phase, so that it gives a cancellation effect to the side, which means that the side, front to side, is exceptionally high. And part of that very deep suppression to the side means that with the correct modeling, you can reduce drastically or remove side lobes. So you end up with kind of a torch beam type radiation pattern from the Yagi rather than having a main lobe and 2 lesser lobes.
And because the antenna is 50 ohms and because it doesn't require a matching network, then if you're putting any power into the antenna, then that antenna is being that power is being radiated and not lost as heat on the antenna itself. Exactly,
and one of the facts, in most cases, the radiating efficiency is well in excess of 98%. And this is another indicator as to the effects of the matching device. You look at a lot of VHF and UHF antennas that are using matching devices, and the input power limit is 1,000 or 1,500 watts. If you're radiating all of that power that's going into the antenna, or the majority of it, and not having that lost as heat, then there's nothing to create that limitation. And we've got commercial applications that are using LFAs at VHF and UHF that are running into many thousands of watts without any adverse effects.
It seems that antenna modeling software has maybe changed the paradigm about what we know about directional antennas. The hex beam comes to mind as something that is an unusual design that may not have been obvious as a design for anybody building an antenna. Are there common myths about directional antennas that we grew up with that you have discovered are not true?
Yeah, I covered a number of these in the ARRL antenna book. I spoke with the guys at the ARRL about 2 years back, and after reading some of the notes in there, I'm saying, well, this isn't actually true because, and this isn't now understood as being correct because. So I did a few chapters on there just covering some of these, but one of them, which I again published in Dubus, was the myth that low impedance antennas or low impedance Yagis are very narrowband and unstable. They don't need to be. It's just the traditional methods of modeling dictate that it makes them that way. And one of the problems was that some very good optimization software came around 25, 30 years ago. Yagi Optimizer and Antenna Optimizer, both by K6STI. And this took a lot of the requirements for optimization away from the user, and the user could just set up a number of basic parameters that they wanted to achieve, and then the software would go off and do it itself. And being hams and wanting to get most people just wanting to get as much gain as they possibly can, they put all of the weight on gain, very little on front to back or SWR, and let this optimization package go off and do its thing. But the quickest and easiest route to gain is boom length. So what the software would do is optimize the various different spacings and the lengths of each of these elements to get a dip in SWR and get an X amount of gain, and then it would move the last director slightly further forward so that there's more gain achieved. And then it would do all of the various different optimization of the spacing between the elements and the lengths of the elements to get another dip in SWR. But the longer the distance between the reflector and the last director, the more narrow that dip was becoming. And the more narrow the dip becomes, the more unstable the antenna is. So then what happens is when you start to get water involved, ice involved, then the resonance and the performance of the antenna shifts drastically away from where it should be operating on. And now you have a Yagi that you can only use in fair weather rather than in all weathers.
What are the best materials then for building these Yagis? You have a discussion I see on your website about the like saddle clamps that are maybe optimized for being degraded by the sunlight on the one hand, and yet because they're carbon-based, they affect the antenna resonance. Can you talk a little bit about the materials that you're using and how you've probably come up with the right combination that will last a long time at the same time as optimizing performance?
Okay, this is it's an interesting subject actually, because many times the production of an antenna in the real world, when you're taking that from model into something that you can use, is about compromise and about which compromises you choose to take. Now, to replicate the model, there's many aspects that need to be taken into account in the model. Generally, in some of the packages that we're using as hams, you don't have the ability to model the boom or the clamps that are holding the elements in place. So I don't get to see the influences that these can have. Furthermore, there's a saying which I picked up many years ago, and it's so true. It was when I was a young lad still at school, and I got a job working in a TV and radio shop, fixing TV and radios with the engineers there. And one of these guys explained to me that, or this particular term, a little knowledge is a dangerous thing. And the example that he gave was that they had this TV set that a radio ham, believe it or not, had decided to try and fix. And he had hooked up his oscilloscope and clamps the clip or the ground clip to the frame, but the frame in the back of these particular TV sets was live, so it took the oscilloscope out. And it's the same, I think, in a lot of ways with some of the materials we use, especially with regards to VHF, UHF, and the understanding of the differences between the various bands and going from HF to VHF is quite vast. And a lot of that is as a result of the lack of respect for frequency and the respective size, if you like. For example, if you have a clamp that's holding an element in place that's 1 inch across, and you use that 1 inch clamp on 70 centimeters, I don't know exactly what it would work out to, but it's probably going to be several feet, the equivalent of, as if you would be putting that on 20 meters. So in terms of frequency, the size and density of the items that are being used are much greater. Now, a common used insulator for holding elements in place on HF would be called polycarbonate. Polycarbonate is very hard and it's very resistant to UV. But now when you go to VHF and in particular UHF, it plays a very different role because it has, as you mentioned earlier, a big influence on the resonance of the antenna. It's not RF friendly, it conducts. The easiest way to challenge that or to test that is if you take a polycarbonate insulator and put it into the microwave oven, you'll find that in very least it will get very warm. In many cases, it will just end up as liquid. Whereas if you use something like polypropylene, it's completely RF neutral. It will stay perfectly cold. And if you experiment with elements on VHF, UHF, and place polycarbonate onto the elements, you will see the antenna shifts drastically and behaves completely different. Different SWR curves, different impedance curves, different frequency of operation. So the antenna is now nothing that you represented in model. Whereas if you place insulators that are made from something like polypropylene, there's virtually no change, if any, on that at all.
Are polypropylene saddle clamps and things like that available in the marketplace, or do you have to make those especially for your line of antennas?
No, they are available. One of the ones that I recommend, and maybe at this point it's good to just add the point about the website, or G0KSC.co.uk. And what it is that I do on that website is give a number of my early designs for anyone to free build for themselves, and information on how to build a Yagi and to get it to work right. And one of the suggestions or recommendations on there is the use of Stauff, which is Stauff, Stauff hydraulic hose clamps. And Stauff, they make these for use in the hydraulics industry for the diggers and cranes and various other applications such as that. And these would hold all of the various different sized tubes that there might be to run hydraulic fluid through. So you get those in both imperial and metric sizes, and in various different materials too. So it's a case of, if it's not broke, don't fix it kind of things, and they are mass produced and pretty good quality, and they do those in polypropylene and in polycarbonate as well. Now the polypropylene version has some form of treatment in it to make it better for UV, but it's not perfect. So what tends to happen is when you get some weathering, it will go, or the polypropylene goes a bit milky on the surface, and it's a bit brittle on the surface, but it's only a millimetre or so deep that occurs. But in very harsh environments where it's very warm and there's a lot of sun, then I generally suggest that the antenna is effectively fixed upside down, so the insulators are below the boom rather than above the boom.
Oh, that's very great advice. I live in Israel, and we have nothing but sun.
Yeah.
So sun and dry weather. So anything that's put outside doesn't seem to last very long under the sunshine. And now this message from QRP Labs. Hans Summers, G0UPL, informs me that he has sold over 5,000 QCX transceiver kits. I hope that in large part this is due to the promotion on the QSO Today podcast of this amazing single-board transceiver kit for under $50 from QRP Labs. The QCX is a feature-packed high-performance single-band 5-watt CW transceiver kit with whisper beacon and built-in alignment and test equipment tools. It is available for 80, 60, 40, 30, 20, or the 17-meter bands. It has a rotary encoder synthesized tuning, VFO A-B split, iambic keyer, CW decoder, and more. You can assemble this kit yourself with standard tools and a soldering iron. There are no surface mount components to solder, as the two SMD ICs are already factory pre-soldered on the board. Of course, Hans has a whole range of accessories to trick out this ride, using the language of hot rod cars. Since Hans has shipped over 5,000 QCXs, there is a rapidly growing community of builders and users who are fine-tuning the QCX in an open-source kind of way and sharing it with us on the Internet. So if you're ready to build your own rig, or want to save money, or just want that prepper rig for your bomb shelter, use the link on this week's show notes page to get to QRP Labs. Please use my link, as it tells Hans that you heard about it here on QSO Today. QRP Labs is my favorite kit company. It should be yours too. QRP Labs. And now, back to our QSO Today. I've read through the years that magnetic loop antennas are quote-unquote quiet. In my research for this QSO, I read that your antenna designs are quiet antennas. What makes a quiet antenna?
Largely, it's around the way that the antenna is modeled. Firstly, one of the benefits of a closed loop is the reduction of noise, and one of the reasons that or where that comes from is the same as with the magnetic loop, is the bandwidth is fairly narrow. Once you go, and while the designs are, or my designs are fairly broadband, they have a flat SWR for, if you look at 6-meter antennas, maybe 500 kilohertz, they would be 1.1 to 1 or thereabouts. once they go out of their operating range, they become high impedance very, very quickly. So anything that's received outside of those bands is drastically suppressed. And it's the same on the transmit side as well. So that's one aspect of it. The second is the way that the antenna is modeled. I mentioned earlier about the sort of old style methods of optimization for a Yagi as gain, gain, gain. Every other aspect of the receiver chain, if you have an old school receiver rather than SDR, is tuned for minimum noise. And the reasons for that, most of us would know. If you tune for maximum gain, the signal to noise ratio drastically reduces. Yet the bit that goes right at the end of the receiver, we've always tuned for maximum gain. And the same issue occurs when you do that. If you optimize an antenna correctly or a Yagi correctly, let's say you get 10 dB of gain. If you now push that to try and get 10.2, 10.3 dB of gain, you may well do that, but you may have reduced significantly the signal to noise ratio of that as a received component. And what tends to happen through my experimentation is there's two sections to a pattern on an antenna, which is very difficult to show without diagrams. But I mentioned earlier the torch beam. If you imagine a torch beam in a dark room as being, or a light bulb, if you like, the shape of a light bulb being the single lobe, forward lobe of the Yagi, and then the threaded piece of the light bulb as being the back lobes, and everything to the side and to the rear, so your front to side and the front to back. When you optimize to go from that 10 dB to that 10.1 or 10.2 dB of gain, that threaded section starts to drastically increase. Now, for every 0.1 of a dB, you can increase the size of that bubble on the back by up to 1.5 dB. So if you put that in reverse and you now say, well, I've got 10 dB of gain and I've got 2 S points of noise, by reducing your gain to 9.8, you could virtually take that noise level away, providing that noise is coming from behind or below or to the sides of the antenna. The second point is that traditionally the optimization of the Yagi has been conducted in the azimuth plane. The optimizers themselves, computer optimizers, are not three-dimensional. They take the pattern at one point, at one angle, so this will be, say, 90 degrees to the side of the antenna, and look to control the side lobes or suppress the back lobes, but in just that one direction. If you do that to the side, we're assuming we've got a Yagi that is horizontally polarized, and we're looking out to the sides, east and west or to the left and right as you're looking down on that antenna and controlling that. When you do that, the elevation lobes remain completely uncontrolled. So while you may suppress the side lobes in the azimuth plane and the back lobes, you can end up with very large lobes directly up and directly down, or slightly forward and in both up and down directions. When you now look at the slice from a vertical perspective, you could have a lobe that's pointing down into your house or into the neighbor's house that's only 10 or 15 dB down on your main lobe. So if they've got a noisy device in their home, that's a prominent feature on your spectrum display on your receiver. What I did to my antennas is apply the optimization in the elevation plane. And what I didn't realize at the time is that when you control the elevation plane lobes, the azimuth plane lobes are taken care of automatically, unlike the scenario in the opposite. So now by having control of those elevation lobes and pulling those down to absolute minimum levels, anything directly below or just off the bottom of the antenna is now virtually eliminated. So if you look at some of the examples of the A/B comparisons that people that have LFA Yagis have run on the internet, you can see marked differences, 1 or 2 S points between their previous Yagi antenna and the the LFA Yagi between this is background noise or effective noise level.
Now, you also have, we discussed LFA antennas, you just mentioned them again, but you also have antennas called OWL antennas. Well, what are the difference in these antennas, and do they have specific applications?
The concept is very similar. The OWL, or optimized wideband low impedance, was produced to represent the nullin, if you like, of the theory that the low impedance Yagi was always very narrow band and unstable. And what my point was in that particular article was that it was just the way that they've been optimized. And when we optimize a low impedance Yagi, the driver cell, as I would call it, which is the first 2 or 3 elements, need to be much closer together than they would be in a higher impedance Yagi. So I was taking a 12.5 ohm Yagi with a split dipole Yagi and showing that the same sized antenna with a 12.5 ohm feed impedance could not only outperform per foot of boom an OWA style Yagi in terms of gain and front to back, but it could also have a wider bandwidth in terms of SWR, which was quite controversial because the OWA was always seen direct fed 50 ohm dipole fed Yagi would be one that you would have that and give up a little bit of gain and a little bit of front to back in exchange for being able to cover the whole of, say, 20 meters without having to use an ATU to retune it. Whereas on a lower impedance antenna, it would only cover part or thereof of the band, and the rest would have to be taken care of with an ATU or something. So by doing that with the 12.5 ohm dipole fed Yagi, you ended up with exceptional performance. However, as I mentioned earlier, I'm not a fan of matching devices. So by swapping the folded dipole for a simple traditional, split dipole, and swapping that for a simple traditional split dipole, you ended up with a 50 ohm direct fed Yagi with exceptional performance. So while they're very similar in the performance characteristics, the LFA tends to have higher front to side because of the bigger side sections. They are very similar. They're still folded dipole Yagis. But what I have done is the designs that I've produced for the OWL, the OWL Yagi, I've produced mechanically different. So they tend to have thicker elements that are bolted directly to a metallic boom, whereas the LFAs are always insulated elements above the boom. So the LFA is bigger booms, insulated elements and bolted to it. That's for more rigid applications, whereas the OWL mechanically is made for more portable and applications or where there's lower windage.
I saw some UHF antennas on your website where the driven element is not parallel to the other elements. Can you speak about this change and how it changes the performance of the antenna?
When you say not parallel, in what respects?
Well, it kind of looks like a jet plane, rather than have its wings straight out, like a dipole. On the driven element is in fact kind of pushed back, so it's in a V shape.
Okay, well, it's those the ones that I produce are the what we call an optes, and it's a bit like the LFA loop, but without one side of the loop. So you've got a straight element with the tips bent back at the ends. Now with that, the bent back section actually becomes the impedance controller. On a OWA Yagi, the first director is generally the impedance controller, and that's distance and spacing between that and the driven element and its length or width is what gets the impedance to 50 ohms. So often some of the performance that could have been gained from that first director in terms of gain and front to back has to be given up in exchange for impedance. The optes Yagi with the bent back tips, that the angle at which the driven element is and the distance between those tips from the reflector and the length of that bent back section is what now alters the impedance. And that means now D1 is given up to be able to be used for performance enhancing attributes rather than giving it up for impedance matching. So generally you get a better level of gain. And that's the highest level of bandwidth that I've been able to achieve is from those. And some of the commercial applications for those include the broadcast band. I made a bunch of designs that run from 87 to 108 megahertz using that method because of its very broadband properties. So when you consider a center-fed Yagi-style antenna without a very large reflector, just using one single reflector covering 20 megahertz at that kind of frequency, it's pretty good. Because on those bands, on 88 to 108 in particular, it's always been the case that very large V-style shaped reflectors have had to be used in order to give the bandwidth that's required on those frequencies.
I see. So the great advantage is that you have a flat antenna over a wider frequency range.
Exactly, yeah.
I see. Well, that's pretty cool. I saw a picture of a vertical antenna. It looks like a 2-meter antenna on top of a pole, but mounted on the side of the pole were quad antennas. It looked like a 2-element quad antennas that are on the side of the rotating mast.
Mm-hmm.
Is that an antenna that you make?
Yeah, they are quads. What it is, again, is a variation of a theme. If you take a close look at that particular quad, they're using tubular elements rather than wires. But one of the big standouts on this is it has 2 booms. There's a boom at the top of the quad elements, and there's a boom at the bottom. So if you had, say, a 4 or 5 element quad, you would have 2 booms, and all of the quad elements are exactly the same height. It's just the width of the quad that varies. Now, there's a couple of, again, standouts in terms of the benefits over traditional quads. Generally, traditional wire quads are around 110 ohm in feed impedance. And if you use a quarter wave of 75 ohm coax at the feed point, you get your 50 ohm feed point. So, as I was discussing earlier on, the higher the impedance of an antenna, the lower the performance generally is. So the lower the impedance you can, or the feed impedance you can have, the better the performance will be. The next thing which is fact is the thicker the element is on any given element, or the elements if we're looking at Yagi or quads, then the higher the gain will be. The lower the thinner it is, the less it is. Now quads have the potential, I say the potential because it depends how well they've been modelled, but quads have the potential to have much higher gain figures per foot of boom, up to about 6 or 7 elements when compared with a Yagi. But one of the downsides in the traditional designs is that we're using very, very thin wires. So by having an antenna which is or lent towards having higher gain and then very thin elements, you're kind of taking away some of what you could have. So now in the terms of these ones where you see, and I think that the mast that you've seen is probably what I have here at Canvey at the moment, which is a 2-element for 6 meters and a 2-element for 4 meters on my VHF tower. You've got relatively thick elements in terms that they're 16 millimeters with 13 millimeter loop end sections. All of those loop ends are the same height, and it's, as I said, it's just the actual width of the elements that are adjusted for the frequency and SWR. But because they're very thick elements, it's conducive with having very high gain. So on the 6 meter one, for example, that's just 2 elements, and it has a 53 centimeter boom. So that's just over half a meter. So that's about 18 inches, the boom length. But that's 7.6 dBi in free space. So when you look at it in terms of feet, it's a very significant amount of gain for that size boom. But also the fact is that with the beam width of a directional antenna is controlled largely by the boom length, or the distance between the first and last element. So therefore, because the first and last element in this case are very close together, it has that 7.7 or 7.6 dB over a very wide catchment area, around 80 degrees. So they are exceptional. The second thing and point to that is that I've optimized them for a direct 50 ohm feed point, so they can be direct or directly connected without the need for any quarter wave matching lines or anything like that. So of course all of the power limitations that come with such a matching arrangement are removed.
You contribute to Dubus magazine, and you mentioned it earlier. For listeners outside of Europe, what is Dubus magazine, and how do you contribute to it, and who is it for?
Dubus magazine, until I was approached, I wasn't familiar or aware of it either, but it's produced in Germany by Joe Kraft, and Joe will be really upset with me for not remembering his German call sign. But one call sign that a lot of people, particularly on 6 meters, will know, which is his, is CT18CD, or Charlie Tango 1 Hotel Zulu Echo. And that's because every time there's a 6 meter opening to Europe, Joe is one of the first people to be heard. He uses he has a home in the Algarve, not far away from the coast, and he uses a 9-element LFA for 6 meters. And he's always one of the first to be heard and one of the last to be heard stateside. Now, he's the editor of the magazine. It's produced in German language and in English, so there's a double for each article. And it's technical articles for VHF and uppers, if you like, and is distributed around the world. So those real enthusiasts, the EME guys, the weak signal guys, the microwave guys, will generally know of this and subscribe to it. And I think it's dubus.org is where the site is where you can subscribe to it. So generally what happens is a lot of people like myself will produce technical articles, or maybe not so technical. In my case, I tend to keep everything in plain text, so it suits all audiences. And they present those to Joe, and he produces this every quarter. And it's normally a very thick publication with some very useful information in it. And there's many antenna designers and innovators that publish in there too.
What kind of antenna modeling software are you using, and are the same software that most hams are using?
It's a good question. There's a lot of different packages which can be used, but some of the traditional packages which are used by hams are using very old electromagnetic calculation engines, in particular NEC2. And it's an important thing to discuss because it's one of these areas and one of the questions that I'm asked quite often about LFAs, and can I have the model on this? And I use EasyNEC. Now, NEC2 is now open domain. It's free where it can be used on anything. So, but it hasn't had any development for 30 years. So if you go out and buy something like EasyNEC, the $100 version, EasyNEC 6, whatever it is, and the $100 version, it will have the NEC2 engine. And for most antennas, for straight wire Yagis that don't have tapered elements, it's perfectly acceptable and functional. If you want to start measuring accurately and modeling accurately antennas with tapered elements, and in particular, or tapered elements, bent elements, and in particular antennas that have bent and tapered elements in the same model, then you need to have something that is a little bit more accurate. Now, NEC 4.2 is the current development version of the NEC engine, and it's the Lawrence Livermore partnership in the US, which is government funded and run, which produced that. Now, to run that in a package, a ham familiar package, then you need to obtain EasyNEC Pro /4, and rather than $100, that's now $650, or it was the last time I looked. And then you have to buy the license for NEC4 from the Lawrence Livermore partnership, which I think if you was a US citizen, it was $300. If you're outside the US, it's about $500. Well, that was the last time I looked, and those amounts or figures may have increased since then. And the reason I say those particular packages is that that's what most people are using. And on the G0KSC site, where I publish a lot of these antennas, a lot of hams, we're all experimenters. They would like to see the models that they're going to build and be able to experiment. And I have to explain that it's not going to be perfectly accurate in the NEC2 versions. You need the NEC4 versions. I did have a license for FECO, which is a commercial package, which is made by a company that's run in South Africa, Germany, on the basis that I was presenting that my findings on the G0KSC site was using their software. But what I established is that up to sort of 500 megahertz, where I'm operating with, the NEC 4.2 engine was extremely accurate. Unless you did something very wrong, there wasn't much variation. And although in FECO you can model the influence of booms, attached coax, insulators, the bolts holding the insulators in place, etc., once you get a feel for what you have to do and the respective frequency, which I mentioned earlier on, and the physical size in terms of frequency that certain components can be, then you can model accurately within NEC or Easy NEC without having to have the extended model building that would be required to put that into something like FECO. And that also means that the models that I have are then digestible by Mr. Average Ham. The other one that can be used and is free is 4NEC2, which is produced by a guy called Arie Voors in Holland, who ironically isn't a radio ham, but he keeps that product up to date. And it also has the ability to accept the NEC4 engine or NEC 4.2 engine if you have a license for that. And that's a very in-depth program. It has some color displays which you can see, and it also has a semi-automatic optimizer which you can use. And I've used that on some of the models that I've developed also. So in its standard free to download form, it has the NEC2 engine. If you then purchase the NEC4 engine, you can put that in there, and it takes in the Easy NEC files as well. So the answer to your question is predominantly EasyNEC Pro 4, 4NEC2 as a side one, and then there are some other programs which I use from time to time as well, just to validate the models. But generally, I kind of know on the ham bands I'm developing stuff now where the flaws lie and how to overcome them.
Now, we've kind of danced around the subject of your business, Innovantennas. Can you talk a little bit about your business? When did you start it, and how it's evolved from there?
Sure, yeah. Well, what happened is it was around, back end of 2007, 2008, I published the G0KSC website, and people were able to build antennas or Yagi designs, which I placed on there. And because it was launched with the LFA Yagi, which was published as this low noise Yagi, a lot of people had the issues or the same issues as I was experiencing, so were keen to build this and install this. A lot of people had great success with that and enjoyed the results that they were seeing. And some of those users were coming to me saying, look, I'm not a builder, I don't have the tools, would you be able to make one for me? Because if you do it, then I know that it's done right. So I think it was, 2010, I decided, look, I'll publish on the G0KSC site that I'll be able to make or a selected number of antennas for people. And that was on the 12th of February or thereabouts. It was sort of second week of the month. By the end of February, I had close to £15,000 worth of orders. I thought, damn, I need to think about this. I'm not going to be able to do my day job and this as well. And while I'd moved on in what I was doing in the telecoms world, and I was flying around the world consulting on how to prevent telecommunications network from being hacked. If I was to move into an antenna business, I was going to end up making a lot less money than I was then. But it was something that I really enjoyed and really felt that I would get a lot of value out, and perhaps was in a position where I maybe didn't need to work quite such long hours, or indeed need to earn the same as what I did in yesteryear. So on the basis that it was clear that there were three types of ham, if you like, with regards to antennas. There were the guy that would always build his own stuff, the guy that would always buy his own antennas, and then the one in the middle that would do whatever was easiest, build or buy. I decided to set up Innovantennas to produce those. So the great thing is that it appeals to a niche market. You know, the way that they're built, they're made with marine grade stainless steel, very high quality aerospace grade aluminium, and basically no expense spared. One of my directives was to build every antenna, if you like, as if it was my own, so that they weren't the cheapest on the block, but it ended up being that a very high percentage of people that wanted my antennas were having this for this band, this for this band, 8 of this particular Yagi for EME on 2 meters, and 6 for that particular band on 70 centimeters. And now one of the biggest audiences for me are the EME and weak signal community. So we're selling 2 and 4 antennas to each of these guys that are going on H frames and systems for pointing and bouncing stuff off the moon. So it's a pretty good business to be in for me, because I'm now in a position that I haven't been in for many years, and although it's sort of 8 years or so, I enjoy getting up and doing what I do each day, whereas it was getting, I guess, a little monotonous from what I was doing in previous life.
Are you building antennas now just to order, or are you building antennas for stock?
One of the issues that we've got is we do build stuff for stock as well, but the nature of the environment is that it is very peaky, biased towards the summer. So if you've got enough staff to build everything you need to be available all of the time, then you have a lot of people twiddling their thumbs in the winter months. So you have to come up with a happy medium and try and build all of what you've got orders for in the winter, plus a few more. So you've got a bit of a buffer stock as you run into summer. And then, as we're building most of the antennas in southern Spain now, which was the decision on that was to avoid potential Brexit issues. There's a 2-week break time in August as well. So we have 100 or so antennas which are in stock. But one of the problems, self-generated problems, is that there are a lot of models on each band, rather than just being a few, 3 or 4 antennas for 2 meters. We'll have a 3 element, 4 element, 5 element, 6 element, all the way up to 22 elements for 2 meters. So if somebody in a similar situation to me has a postage size lot, and they have 6 meters of turning radius that they can put an antenna in, they don't want the one that's got 4.5 meters turning radius or the one that's got 8 meters turning radius. They want to use the maximum space they possibly can. So we cater for a much wider audience than most people would do, and in particular those with the restricted spacings. Because of that, because there's so many models, you can't stock too many of everything and have to sort of stock the most popular stuff that you can. But at the same time, we have a lot of very unique commercial requirements too. We have some of our customers include the US Navy, for example. One of the LFA Yagi being very quiet and having very high front to side and very good front to back means that for a ground station with a Yagi pointing out to sea, you've got very little generated noise from the side and from the back. So what you want to receive out at sea you can receive better on that than you can on NAVA antennas. So the US Coast Guard as one of our customers, and they have LFA Yagis for receiving AIS signals, or the automatic identification system, which is a low power ID that has to be sent from each ship, for example. We also have military customers in the UK and other locations where they've had small specific applications that low noise antennas have been required for. Some of those for some organisations have been in what have been described as warm, sandy environments where they've needed point-to-point Yagis that are pointing each other, and they don't want too much to be sent out towards the sides of those antennas or from the rear to be sniffed by anyone that they don't want to receive those signals. So there's all sorts of stuff outside of ham radio that we're catering for as well. And when you get one of those that is a little bit higher than you would normally expect, we have an application for 5-element LFAQs, the quad Yagi, which we were just discussing, for a frequency in the lower 150 megahertz range. And that there was quite a bunch of those, about 50 of those, that were required by a company which were monitoring the movement of wildlife in Australia. So those were being installed to receive transponders. And because of the high gain and the very rigid way in which they're constructed, they were ideal for their particular environment too. So it's, I don't know if that, it's a bit of an indirect way of answering the question, but...
in other words, you have a business.
Yeah, right, yeah.
It's no longer a hobby. It's now a business.
Exactly.
Congratulations.
Yeah, thanks.
Yeah, that's cool. What kind of impact has amateur radio had on your family life?
Well, I have one of the most understanding wives in that respect. She knows that when we met, which was 28, well, it was over 30 years ago, we've been married 28 years in June just gone. I was already very much into the radio, and I remember my wife and I driving to Wanstead in East London on a very foggy evening, which was quite away from where we were both living at the time, and her waiting in the car in the cold while I took my CW exam for me to come out. So she's very understanding, and obviously we both run a business in the business now, and we've been fortunate enough to make a lot of friends before and after setting up the business, and travel to many amazing stations and people around the world. So, it's a case that she's very welcoming and understanding in that respect. And unfortunately, my two sons that are grown up, which are 23 and 27, they don't have an interest in radio at all. But while she's not a ham herself, she is accepting of it and understanding that this is, we've got a great deal of friends in this hobby, and it's how we make our living there as well.
What excites you the most about what's happening in amateur radio now?
For me, I guess it's a little bit biased because of the interests that I have. 6 meters is my I mentioned about 4 meters, and I do enjoy 4 meters, but 6 meters is my first love, if you like. I remember years ago, my second radio was a FT767, and I remember hooking this thing up and just listening on 6 meters. And what I didn't realize when I bought the radio was back then that particular model didn't come with a microphone. So I unboxed this thing and set it up and plugged it in, and I hadn't had 6 meters on the 140S. So I went on there and I tuned it to 50.110, and there was a VK called MCQ with no one answering, and it was just so frustrating because I couldn't go back. But that's where my interest in 6 meters started. And now, with the introduction of much better receivers, things like SDR radio, whereas on my setups in both Spain and here consists of large 39-inch 4K monitors, and I have 3 slice receivers open at any one time. One is on the lower CW section of the band, one is on the top beacon section, and the one in the middle on the digital modes. And if there's a sniff of any signal anywhere, I can see it. And it's the same for many people around the world now. And then with the introduction of things like low noise Yagis, and many hams around the world installing 2 and 4 antenna systems, even in the most marginal of openings, serious distances can be made. Even up until a few days ago, in the morning you're working from here, Japan in the morning, and stateside in the afternoon. And I think for me it's a combination of the antenna technology, the radio technology as far as SDR is concerned, and then the combination of the digital modes and information that can be swapped that mean it's become a lot more interesting. There's a lot more that can happen on these upper VHF bands that perhaps wouldn't have happened previously, or we wouldn't have known that these openings were there. Just and while again it's maybe a slightly controversial to some, and I think it's almost a cheat to be using something like FT8 and put a CQ call and go to PSK reporter and see that your signal is being received in North America and the Caribbean, and know that there's an opening in those directions. You maybe then go down to the CW portion of the band and put out a few CQs, knowing that you're getting there, rather than thinking, well, is there an opening there or not? So it's all these various different applications and hardware capabilities now for me that are making it a little bit more exciting than perhaps it was a few years ago.
What advice would you give to new or returning hams to the hobby?
Well, I think the first thing is, if they haven't bought any hardware already, is to have a good look around at what hardware is available, and also to join some of the forums and perhaps social media groups that are discussing some of the newer applications like JT65 and FT8, to see if that's going to be their thing or not. I know there's a lot of discussion about FT8 and that it's killing SSB and CW, and perhaps in some respects it is. And I was speaking with a ham yesterday who's saying that it's supposed to be a weak signal mode, and if I listen to the FT8 frequency on 6 meters, I can see and hear the signals because they're so strong. And why aren't these people down working, or the Japanese on the CW portion? And my reply to that was that, well, the Japanese signals you can't hear even on CW, but they can be decoded by the capabilities of FT8. The strong signals that we hear were the people in Europe calling those Japanese stations that can't be heard. It might be that those new returning hams really don't want to do digital modes and want to stick with the more traditional stuff. But if they, rather than taking on second-hand equipment or a lesser specified radio, going to something that has a built-in PC interface and is very easy to hook up to a computer, would give them the ability to have access to some of the later modes or emerging modes that there are available, and maybe some of the future stuff too. And certainly the same for on the antenna side. There's so many antennas now which weren't around yesteryear. You mentioned one, the hex beam, which is a very compact antenna that gives directional performance and is very lightweight and easy to keep up in the air with a simple rotator. That if Mr. Joe Ham goes out and buys the same or similar trapped Yagi that we had a few years ago, may fall short a little bit on performance, or have to have a bigger tower or mast or rotator in order to keep that up in the air. So that would be really it, I guess. The summary is do some research first, look at the internet, speak to the hams and how for them the hobby has evolved over what it was for them maybe 10, 15 years ago.
Well, it's funny that This question I hear a lot in a lot of these interviews about whether or not the digital modes is killing single sideband and CW. But it seems to me that the being at the bottom of the sunspot cycle has killed CW and single sideband and not the digital modes. And if anything, the digital modes are keeping people active in the radio and on the air in spite of being at the bottom of the sunspot cycle. What do you think about that?
Yeah, I think that is the case, but I think in terms of bands like 10 meters and 6 meters, the openings and the strength of signals are generally much less. And it may be that it's very, very hard work on CW to be heard. And also, if your signal is in and out and someone's tuning up and down the band, they haven't got a spectrum scope, they could tune past the frequency in which you're sending on at each of your lulls, each of the points where QSB has gone to its deepest. So as far as they're concerned, there's nothing on the band. If they're looking on a band scope that's on a radio, which doesn't have huge amounts of depth of ability to see weak stuff, they may see no signals on the band as well. You know, one of the advantages with some of the better SDR stuff is you can see traces of signals that are not even audible yet. And I think that's one benefit for the CW user if you're looking at traditional forms. But with things like FT8, you haven't got to move anywhere or tune around the band. If there's going to be a signal, it's going to be where you're listening right now. And if it's even if it's marginal, if there's enough to decode, you're going to see that signal appear. And I think, you know, I leave it running on FT8 on the bands that I'm using most of the time as a personal DX cluster, if you like, to see what's happening and where, even if I'm not using the radio at all. And I'll glance up at the screen and see if there's any signals and where they're coming from. And it may be that, you know, if you've got some serious DX as it has been this year, there's only been 1 or 2 days during the course of June that Japan were audible to work CW. I worked 2 Japanese stations CW. I've worked dozens on FT8. But when you looked at those signals, you could see them on the band scope while we're working those JAs, but they weren't audible. Those signals weren't audible to work. So I do think it comes back to the little knowledge is a dangerous thing, and maybe a lot of assumptive opinions that are being formed from without actually drilling down into the facts in a lot of cases. I think it's you know, the sunspot cycle is at the bottom, signals are weaker. It could be the case that if you didn't have the digital modes, there would be nothing happening whatsoever. As it is, these are given the ability to do some real DX with signals that otherwise wouldn't be heard.
And buying antennas that optimize their ability to push that signal in the right direction, seems to me.
Yeah, and by buying antennas that are optimized for signal-to-noise ratio rather than just outright gain. So you have the ability to hear weak stuff, not just to be heard. You know, how many stations do you hear on various different bands that are real loud that they just can't hear what's replying to them? And yeah, okay, it may be that they're running power and the guy that's replying to them isn't. But isn't that more reason then to have an antenna that's optimized for a few tenths of a dB less gain, but has a much better signal-to-noise ratio so that they can hear? That few tenths of a dB is not going to make a lot of difference from that stateside station that's running 2 antennas and 1,500 watts. But the guy at the 2E0 in the UK that's running 50 watts on his wire, he's not going to be heard unless they've got a very low noise setup.
If you don't mind my asking, you know, it's the entrepreneur question. When you got that first orders, did you have the capability, like in your garage, to, you know, cut all that aluminum stuff, or did you have to find a subcontractor that would go and build it to order for you? How did you do that?
Well, what I had done is a part of the modeling that I was doing back then, and when I was coming up with the concept of the LFA, I had to make it to see if it worked. And what happened when I was using just the NEC2 engine, and when I built the first LFA, it didn't work, and it was some other frequency, a megahertz or so away, and not quite as I was expecting it to be. So I was scratching my head, and then when I did the research and saw that this NEC4 engine was the the latest version. I took a leap of faith and $1,200 and purchased the software and reversed engineered the model that I had. And basically when I put in the dimensions that I had adjusted this antenna to into the NEC4, it worked out right. But of course, that was part of the early stage development. And for doing that, I couldn't just be having a tube over my lap and cutting it with a hacksaw. I purchased different bits and pieces along the way. So I bought an old milling machine, like a hobby mill, a smaller one, and I had that in my garage. And then a chop saw. So I'd had these for building the prototypes and testing the stuff before I was publishing it on my own website. So I had the means to do it, just wasn't expecting the amount that came in. So my father that was retired, he would come around during the day and we would build these things. And in the end, he had a much bigger garage than me, so we moved the stuff around to there and started it from there, and that's how it all sort of...
Well, that's amazing. Your father, does he still work in the company?
No, because everything's pretty... I have one guy that's producing stuff here for us, and that's mainly... When we moved down to Spain, we also changed then to metric tube sizes and everything else that comes with Europe. In the UK, we still have imperial tube sizes, so 1.5 inch, half inch, everything else. So I've got one guy that produces parts for people that have dropped a tower or whatever, or maybe it's the case that they bought 2 of our antennas and now they want to upgrade to 4, so they need them exactly the same as they had before.
Oh, interesting, because your tube sizes obviously changed the tuning of the antennas, right? So when you went from imperial to metric, you had to redesign the antennas.
Not redesign them, there was adjustments that needed to be made. The adjustments electromagnetically were minimal, just a few millimeters to the tips. But the mechanical design changed drastically, because one of the considerations you need to make is to maximize the use of each length that you buy. So if you've got a given tube size or diameter, in the UK it comes in 5 meter lengths. If you're tapering an element, then you need to allow for the saw blade widths and then each section to maximize the usage of a 5 meter length. So you maybe end up with 10 or 15 millimeters of wastage out of that 5 meter length. When you go to metric sizes in Spain, they're now 6 meter lengths. So your taper lengths need to change in order to maximize the usage and minimize the wastage per length. So where like now we're using 830 millimeter sections and there's 100 millimeters of overlap. So into each other tube, and that gets the most out of the section lengths that we get.
Well, that's amazing. And you've got software or spreadsheets or whatever that you've designed in order to reduce your wastage and stuff like that. I mean, it sounds amazing.
That part is to reduce the wastage is just all manual. But from the mechanical design, what happens is I need to get the taper sizes, which works best, and then put them into a mechanical Yagi modeling software, which is by K7NV, called Yagi Stress. And that will tell you what sag you will get from those elements on any given band, what wind load it will have, what the maximum wind survival will be, and that kind of thing. And then you can tweak certain sizes or maybe add an extra taper in order to get that to where you want it to be from a wind survival perspective.
Justin, I want to thank you so much for joining me on the QSO Today podcast. This has been a lot of fun. I've learned a lot about antennas that I didn't know before, and you've challenged some of the assumptions that I've been sitting on for 45 years. I'm happy that you did that. With that, I want to wish you 73 and thank you.
Thank you too. It's been a pleasure.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Justin. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in G0KSC in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links in the show notes pages, or when you make your purchases, that you say that you heard it here on QSO Today. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, Spotify, Libsyn, and TuneIn, as well as the iTunes Store. If you own an Amazon Echo, you can say, "Alexa, play the QSO Today podcast from TuneIn." I still use Stitcher to listen to podcasts on my smartphone. The links to all of these services are on the show notes pages on the right side. Until next time, this is Eric for Z1UG73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.